Welcome back, guys. Today's video is going to be covering the four quantum numbers. So quantum numbers are a part of quantum theory. It's a difficult area of chemistry to understand. However, when we look at the quantum numbers, we'll have a better idea of how to describe electrons. So electrons have four quantum numbers that essentially describe what electron we are talking about, right? So every individual electron has its own set of four quantum numbers that distinguish it from other electrons. So let's dive into the four quantum numbers and see how we can start describing electrons with these quantum numbers. So the first quantum number, and they're called quantum numbers, however, we describe them with these letters N, L, M sub L, and M sub S. So it's not necessarily numbers, however, they're just called the quantum numbers. So the first quantum number is N. So N describes the energy level of the electron. So if we go to our periodic table, our rough sketch over here, as we go down the periodic table with rows, so we're not concerned with columns here, we're concerned with the rows going down, right? As you move down a row, you gain another energy level. So hydrogen and helium over here in the first row would be N equals 1. Then as you move down to the second row and go across here, this would be lithium and beryllium, carbon, nitrogen, oxygen, fluorine, chlorine, and neon, right? Those are in the second row. Those would have an N of 2, right? That's the second energy level. And in the N equals 3, right, we'd be in this energy level. So the energy level of an electron is determined by the N value, right? So as you move down the periodic table, you keep increasing your N value. Now, the second quantum number is the L quantum number. And this tells us the shape of the electron's orbital. So if you look back to my previous video on electron configurations, we talked about the three different areas of the periodic table, the three orbitals that electrons can belong to. The s orbital, which is over here on the left, the d orbital, which describes the transition metals, and the p orbital, which describes all these atoms on the right. Now, when we look at the L values that we can have, right, if we're talking about an s electron, it has a L value of 0. So if we were talking about an electron over here, it has an L value of 0. If we're talking about a p electron, it has a L value of 1. So that would be an electron over here. If we're talking about a d electron, it has an L value of 2. And that is just describing the shape of the electron's orbital, right? So it's just assigned a number value to tell us that there are different shapes that those orbitals can be in. Now, in purple, I have written here, this also tells you about the number of nodal planes that an electron has. So nodal planes, simply put, are just an area of an electron where you're not going to have a lot of electron density, right? It's an area with 0 electron density. It's a little bit more complicated than that. However, for a simple definition, we can think of nodal planes as an area in the electron where there is no electron density, right? So we can just count how many nodal planes we have based on this L quantum number. So the L values not only tell us the shape of the electron's orbital, right? S is 0, P is 1, D is 2. If we have an L value of 0, right, that means we have 0 nodal planes. That means an S electron has 0 nodal planes. A P electron has 1 nodal plane, and a D electron has 2 nodal planes. So we've now covered the energy level of an electron, the shape of the electron's orbital, and the number of nodal planes it has. Now M sub L, right, it's an M with an L subscript right here. This tells us the spatial orientation of the orbital. Now, this one is a little bit tricky to understand. However, we can think of it in a pretty straightforward manner if we think of M sub L in relation to L. So, we have these different types of orbitals. We have an s orbital, a p orbital, and a d orbital. Now, these orbitals can be arranged in different ways in space. So, if we want to come up with values for M sub L, the rule of thumb is we can go from plus L to minus L. Now, what does that mean? So if I want to know the possible M sub L values or quantum numbers for an S electron, well, we can go from positive L to minus L. However, when we see the L value for S, it's 0. So we can technically go from positive 0 to negative 0, which doesn't really exist. So we know that the only possible M sub L value for an S electron is 0, right? That's because there is only one way that an s electron can be oriented in space. So this m sub L value tells us how many different ways you can arrange that orbital in space. So if we move on to a p electron, we see that its L value is 1. Now the possible m sub L values for a p electron, right, we can go from plus L to minus L. So we could go from plus 1 all the way to negative 1. So we'd have 1, 0, and negative 1. So it ranges all the way from plus L to minus L. So there is 3 ways that you could arrange a p orbital in space, because it's the spatial orientation of the orbital that we're talking about. And lastly, the m sub L for a d electron, right? We can go from positive L to negative L. So we can go from 2, 1, 0, negative 1, and negative 2. That means that we can arrange the d orbital 5 different ways in space. Okay, so we've now covered the n quantum number, the L quantum number, and the m sub L quantum number. Now this last quantum number is the spin quantum number. Now it's important to note that when we're talking about electrons, nothing is actually spinning. That's why I put this in quotations. It's not saying that an electron is spinning around. What it's saying is it's a way to distinguish electrons if they have the same 3 quantum numbers above. So if you were to have an electron, 2 electrons that both have the same n, the same L, and the same m sub L, one way to distinguish those 2 electrons, because every electron has its own unique set of quantum numbers, what we can say is those 2 electrons with the same first 3 quantum numbers, we'll call one of them a plus 1/2 for its m sub s, and the other one a minus 1/2 for its m sub s. So these are the only 2 values that you can have for the m sub s quantum numbers. So it's important to note that it's not really spinning. However, the way I think of it, it's just a way to distinguish electrons so we don't end up with 2 electrons with the same 4 quantum numbers. That's going to violate a principle of chemistry. So let's go over here and see if we can tackle some of these practice problems. So it says, how many nodal planes does a 4p electron have? So we're dealing with a 4p electron. So the 4 right here tells us that the n is 4. That's telling us the energy level of the electron. So this is a 4p electron, so we know we're going to be in that 4th level on the periodic table. Now, it's a p electron. So if it's a p electron, what I do is look at my L quantum number, and I know that for a p electron, the L value is 1, okay? And that also tells us that there is 1 nodal plane in that electron. And remember, just a nodal plane is that area where there's no electron density. I don't think you need to know any more than that about nodal planes. Okay, if we wanted to continue on with that 4p electron, it does have an L value of 1, right? It's a p electron. Its m sub L values could be 1, 0, and negative 1. And we can assign it a m sub s value of plus 1/2 or negative 1/2. Okay, now for question 2, it says, decide whether the following sets of quantum numbers exist. So we want to go through A, B, and C and decide, do these 4 quantum numbers make sense? Do they describe a real electron? So one thing to keep in mind when we're doing this, when we talk about a p electron, you can only have a p electron once you've reached the n equals 2. So it's possible to have a p electron once you get to the 2nd row. However, there's no such thing as a 1p electron. That's because when we're in that 1st row, we're just dealing with hydrogen and helium, and those are both s electrons that we're dealing with there. Similarly, when we're talking about the d electrons, this starts at n equals 3. So yes, you can have a 3d electron, but you cannot have a 1d or a 2d electron. So let's keep that in mind when we go through these problems. So if we have an n equals 2, and L equals 0, does that make sense? Well, so far we'd be dealing with 2, and let's see, if L is 0, we're dealing with an s electron. So we have a 2s electron, which is fine, and we have an m sub L of 0, right? If L is 0, that means our m sub L can only be 0, right? Because it ranges from plus L to minus L, and we have an L of 0. So that's fine, and m sub s is plus 1/2, which works because as long as it's one of these 2 values, we're fine. Okay, now we have n equals 3, so we're dealing with an n equals 3 electron. L is 2. So that means that we're dealing with a 3d, right? If the L is 2, that is a d electron, right? We're dealing with a 3d electron, which does work because d starts at n equals 3. Now, if this was a 2, that would not work because there's no such thing as a 2d or a 1d electron. However, if we look at the m sub L, the m sub L is 3 here. Now, if our L is 2, our m sub L values can only be from positive L to minus L, right? So we can only have 2, 1, 0, negative 1, negative 2. Now 3 falls outside of that range, so this set of quantum numbers is not going to be true. It was fine for the n and the L, but that m sub L, makes this set of quantum numbers invalid. Now lastly, if n is 2 and L is 2, we are saying that this is a 2d electron, and we know that 2d electrons don't exist because d starts at the n equals 3. So this is an invalid set. If we look at the m sub L, that was fine, but if we look at m sub S also, m sub S can only be plus 1/2 or minus 1/2, and this is a value of 1, which also makes it invalid. So it's important that you know the quantum numbers, know what each one of these means, and you can go through and decide whether a set of quantum numbers exists. So thank you for watching this video, and make sure to check out the channel for more videos.